So good morning, everybody. My name's Kevin. I work with BASF Canada. I am a residential construction specialist, and I work the province of Ontario with builders, architects, framing crews, assisting with the process of energy efficient construction. I've got two of my colleagues here with me today. I've got Hugo Beauregard. He is our Canadian team leader, and he's based out of Quebec. And I've got my other colleague, Stefan. Stefan looks after Western Canada. The system we're going to talk about today is the BASF HP wall system. And what's driving this type of construction is the changing energy codes. So Canada is on a journey to achieve full net zero construction strategies across the country by 2032. Some of the code changes that are driving this process, they want mandatory blower door tests, and that was rumored to be starting next year. They've got no max air exchange goal set for that yet, but they're focusing in around 1.5 air exchanges to start on that. Renovation upgrades, that's also coming. No thermal bridge exceptions, and that's going to be one of the advantages we're going to talk about today. Minimum R5, so that A1 compliance package with SB12 will be gone, and they're going to want triple pane windows in there as well. Some of the other things you're looking at is insulation under slab. They're going to have higher R values required for the continuous insulation, and by the time we get to about 2022, you're going to have set max air exchanges that they want in the way of air tightness. The HP wall system from BASF is approved for National Building Code and Ontario Building Code. It's also approved for the building codes out west. In BC, for example, they're following the STEP code. In Alberta and Saskatchewan, it's Part 9. It's compliant with the codes in Quebec as well. So it doesn't matter where you're using the system. This system not only will be approved with all the current requirements, but it's approved as the codes change in advance. And the advantage to you guys is there's no more guesswork and trying to figure out, well, what's going to work this year? What's going to work in 2 years from now? It gives you a cookie cutter template from which you can do your home designs and build from. So the key components that make up the BASF HP wall system consist of our Neopour rigid insulation. Rigid insulation, it's got a density to it of 1.35 per cubic foot. It's a breathable EPS, GPS insulation. The advantage of the graphite enhancement is that it deflects radiant energy. And the fact that it breathes gives you a truer R value in the way of performance. So instead of the materials losing R value when the weather gets colder, the R values actually increase when you need that performance to improve. Wall-tight 2-pound closed cell spray foam. That is the interior insulation that goes into the wall cavity. That is actually 3 products in one because it's your insulation, your air barrier, and your vapor barrier. It also has a structural component to it, which enhances the strength of the wall to the point where we're going to show you that that wall would be stronger with our spray foam than if it was framed with traditional OSB and 2x6 studs. NP1 Acousti-Seal caulking. That completes the air barrier system in the sense that when we're putting our spray foam in that cavity, on the exterior side, you still have a few potential air leakage liabilities that need to be sealed. And that's the advantage of what the caulking does. And then the final components to the wall system are Tyvek 3M 3015 membrane tape and our HP Flash, which is used to seal the windows, and I'll be covering that shortly. There's a few key tools that you'll need when you're working with the system. The bulk of the tools that you use are consistent with what you use now, but when you're fastening the Neopour rigid insulation to the framing membranes, you're going to need a cap nail gun from Boss Stitch with the little cap nails. If you're framing with Neopour thicker than 1.5 inches, there's different caps and nails that go with that assembly. Caulking guns. For the sausage tubes that the MP1 comes in, we use a sausage gun. They come in battery format, or you can use traditional hand pump. They're so much nicer to work with the sausages than traditional cartridges. You get better flow from that. The timber nail gun that you see up there, again, if you're working with Neopor thicknesses that are thicker than 2 inches, you're going to need a gun that's going to drive at least a 4-inch nail so that you can fasten your strapping to that wall and penetrate into the stud at the correct depths. Alternatively, depending on the thickness of the Neopor, at 2 inches you could also use a screw for that. And there's the screw gun that you can use as well if you're looking to attach your strapping to that. So assembling the BASF HP wall system. The assembly process is consistent with which you're accustomed to, but there are a couple of changes that happen as you're assembling the system. The key feature about the XR series is the way that it reduces thermal bridging is far superior to what we're currently doing. So if you're framing a wall with traditional 2x6 studs on 16-inch centers, you can reduce thermal bridging by switching to on 24-inch spacing, or you could stagger studs. However, when we subject these walls to the proper testing, building in a 2x6 top and bottom plate with 2x4 studs on 16 centers and running horizontal girts on 24s, the reduction in the thermal bridge just from the framing process alone has tested and proven significantly higher than staggered studs or framing on 24-inch spacing. So when we go through the assembly process, you're going to start with your traditional format, lay out your 2x6 studs. And when you're running your MP1 caulking, all your 2x4 studs are going to be spaced on 16-inch centers. Double top plate, as you traditionally do, 2x6 bottom plate, and you're going to be using 2x6s for your window and door assemblies, for your jack posts. When you're running the air sealant, we're going to run a bead of that MP caulking. It's going to go between your top plates. You're going to run a bead of it under your bottom plate. And then essentially anywhere where you have wood that meets wood, you're going to seal those air leakage liabilities. When you run your jack posts around window openings, okay, if you have multiple 2x6s stacked together for that, or you're using point loads in the wall, you caulk every single seam where wood meets wood, okay? And we're also going to caulk here in the interior corners where you've got the 2x4 meeting the 2x6 and that your girt sits in that assembly. Your 2x4 girts are spaced on 24-inch centers, and there is a strip of 1/2-inch plywood or OSB that goes in there so that when the girt sits in the frame, it sits flush to your framing members. And that way when your Neopor rigid insulation goes on, everything sits level and you're not going to get waves. So once you've got all of your framing done and you've got all the caulking in place, then you're going to proceed to lay out your Neopor sheathing. When you're fastening the Neopor sheathing to the framing members, the spacing of your nails is the same as if you were framing with OSB or plywood. So on the perimeter, we're going every 6 inches and we're running nails every 8 inches through the field. Once the Neopor has been attached, to apply your weather barrier, there are 2 options. You can tape all the seams of the Neopor with the 3M 3015 tape, 4-inch thick, or you can wrap the house traditionally in Tyvek. And of course, you'll tape all your Tyvek seams with traditional tuck tape. Once that's done and your walls are up, you go about sealing your windows. Now, depending how you seal your windows, if you're using Tyvek, the Tyvek folds in, and again, you'll use that 3M 3015 membrane tape to seal that opening. But before the tape gets applied, all the corners in the windows have to be caulked using that MP1 sealant because you've got air leakage liabilities there. So once that's caulked, we run a strip of tape on each of the corners and then we tape the entire perimeter as you see here as an example. Alternatively, you can also use the BASF HP Flash liquid sealant. The liquid sealant gets spread on like drywall mud, just with a drywall knife, a spatula. And once that sets, it sets like rubber. When you're doing your exterior cladding, sorry for the feedback. If you're doing brick, You run your brick veneer right up the exterior surface like you normally do. Your brick ties go in on the 24 girts, okay? If you're doing siding, you're gonna strap the wall with 1x3 strapping. And again, depending how thick the neoporre is, you'll either fasten that strapping with the timber gun if you're 2 inches or thicker on the exterior, or you're gonna use a screw. What's nice about the screw is when the siding guys come in, if they need to play with that strapping and adjust it to ensure that the siding goes on straight, it gives them that flexibility to do that, versus with a nail, they don't have as much play with it. And then of course, depending on the siding, whether you're running vertical or horizontal, the system pretty much works with any type of exterior cladding you want to put on the outside of the house. If you're running vertical siding, we suggest you double strap or you'll run your strapping on 45s. There are some sidings out there that don't require you to strap the wall. So if you want to attach the strapping direct to the neoporre, you can do that as well. You just got to make sure you follow the manufacturer guidelines for those types of siding. We've got a quick video. So this video basically gives you a fast track of what the assembly process looks like as I just walked everybody through it. Now, when you put the spray foam in the cavity, it's important that if you're spraying direct onto that neoporre, the spray foam contractors start with a 1/2 inch flash. That sets. If you spray more than a 1/2 inch in a single pass, it can compromise the neoporre. Once that 1/2 inch pass is set, they'll come back, they'll apply the additional 2 inches. The minimum amount of wall tight that can go into that cavity is 2.5 inches to meet all of the codes and whatnot and the testing that we've done with the system. One thing I wanted to show you is once that wall's assembled, here's where the advantage to the thermal bridge reduction really shows. If we hypothetically put 2 inches of neoporre on the exterior of that wall and you put 3 inches of wall tight in the cavity, the effective R value on that, which is after thermal bridging impact's been deducted, you're gonna get an effective R value of 25.5. Now, if you frame a traditional wall with 2x6 studs and an R24 bat, and you put no continuous insulation on the exterior, you'll get maybe around an R16 effective. If you add 1 inch of continuous insulation onto that exterior framing with R24 bat, that'll boost your R value to R17, R18. So you can see the difference that it makes when you reduce that thermal bridge. If you were doing that conventional assembly and you spaced on 24-inch centers or you staggered your studs, from the testing that we've done, it may boost that R value from an 18 to maybe a 19 or a 20 even. So by building with a 2x6, 2x4 format, you've got a significant improvement in R value, and that structure is good under Part 9 of the code for up to 10 feet walls. Once you exceed 10 feet, you can still build with this format, but you'd switch your top and bottom plate to 2x8 studs using 2x6 in the cavities, and you can still achieve the same results there. So some of the benefits of building with our system, you're gonna get higher effective R values, you're gonna get greater air tightness. You're getting a cookie cutter system that's tested and proven, there's no guesswork. We've got our CCMC number approvals, you're getting third-party TER engineered testing reports that verify all of the results that we've talked about to you today. You're current and future code compliant. You've got low global warming potential scores to these materials, and if you're of passive house mind and you're green conscious and environmentally conscious, those global warming potential scores are important. And we can talk about more of that later if you have questions on the specifics of that, but you're definitely dealing with products that are environmentally safe and friendly inside and outside. We've got all your code approvals. The big advantage of framing this way is to meet the higher level of energy codes, walls have traditionally been getting thicker and thicker. So to properly insulate your house, you've been losing footprint and sacrificing living space. This wall system allows you to maintain a larger footprint and keep that extra living space without having to build too thick of a wall. You can eliminate that OSB sheathing, and building with the XR system, it will reduce wood use for up to about 25%. And you've got cost competitive to conventional framing. So if anybody is interested in learning more about the system, one of the services that we offer you is if you send my colleagues and I your drawings, we'll do the takeoff on the materials and labor, and we can provide you cost competitive and analytics that will show you the cost to use our system, materials and labor, compared against conventional framing. And then, as I mentioned earlier, the system has tested so that it is structurally stronger than a conventionally built wall using OSB and 2x6 studs. Any questions? So the question was, she's asking about the retrofit industry. And we have another version of the system. So there's actually, the system started with 3 versions. There's the XR, the E, and the X, and I'll explain those differences. The R series is designed specifically to accommodate the retrofit industry. So if you're stripping off exterior cladding and you want to re-insulate from the outside, our system will meet those requirements for you. One of the changes in the code, though, is if it gets passed, they want the exterior upgraded. So they're going to be pushing for the exterior insulation on the outside of the house. How that's going to be enforced, we don't know. We haven't heard much on that yet, but that's the direction they're pushing in. Yeah. So labor-wise, in the cost analysis that we show you, we've used about $54 an hour as the labor rate. That labor rate will vary depending on where you are. We've got 200 some odd projects across Canada now that we've done to date. So we've been framing with crews out west, Ontario, Quebec.
Only for 2019.
For 2019, yeah. But when you talk about labor rates and when you're on site, for the builder, your costs stay the same, but all you're doing is shifting money around. The framers pick up a couple of extra tasks with the caulking. The horizontal girts are a little different, right? But net cost to the builder usually stays in the same range, because now your building envelope and your framing is in the hands of one trade. So whereas you used to have to pay somebody to caulk from the interior side, somebody else might come and strap it when they put the siding on, your framer's doing everything. So even though framers, it might add a little bit of time because there is a learning curve on their first build, but by the time that they've done 2 or 3 builds, the time difference to frame this way versus conventional, it is minimal. And they may ask for a little bit of extra money, but like I said, it's not going to increase your cost that much that it's going to be a deterrent to use. So the other service that BASF provides to make sure that the job goes on track and that it doesn't go sideways on you is that we're there on site training the framers. So we'll be there for the entire assembly process. We'll work with you, the builder, and your framing crew for your first 3 projects, and we're there from start to finish. And that way we can coach them, we can address questions as they come up, but we can keep the project moving in a timely fashion. By the time that they're done, most of the crews pick it up very, very fast, and they're good to go without us.